Hello class, today I'm going to go over the end of chapter 5 that we didn't get to cover in class. So I have the notes printed out, and what I went ahead and did was I numbered the notes vertically 1, 2, 3, 4, 5, and 6, and then so on. And so I'll be kind of referring to the slide numbers that way if you want to do the same, so you can keep up. So the first one I'm going to go over is going to be on slide number 28, which is a follow-up of what we did in class on Mendel's experiment of the green peas and the yellow peas. And so on this case, or we had the same, well, the p is going to remain the same and the q is going to remain the same. So this is the probability of a green pea, and q would be 0.25. Because we're going to start on 28, if I read that, it says use formulas 5, 6, and 5, 8 to find the mean and standard deviation for the numbers of peas with green pods when groups of 5 offspring peas are generated. Assume there is 0.75 probability that an offspring pea has a green pod. So if you refer back to the formulas on the previous slides, formulas 5, 6, and 5, 8, you'll see that for the mean, or the expected value, it's the mean equals n times p, and then for the standard deviation or the variance, you have n times p times q, and of course the standard deviation would be the square root of that, so n times p times q. Okay, so then if we actually wanted to calculate on this problem, they're referring to groups of 5 p's, so that's n, and the probability is 0.75. So the mean would be 5 times 0.75, okay, which would be 375, okay, for our mean. And our variance would be n times p times q, so that's 5 times 0.75 times 0.25. And then of course our standard deviation would be the square root of that. So for this one I will use a calculator to gather that, and you get 5 times 0.75 times 0.25 is 0.9375. Okay. And over here we're just going to take the square root of that, the square root of 5 times 0.75 times 0.25, which would be 0.968 for the standard deviation. Okay, so that answers that question to find the mean and the standard deviation for groups of 5 offspring peas. So we'll move on to slide 29. It says, in an actual experiment, Mendel generated 580 offspring peas. He claimed that 75%, or 435 of them, would have green pods. The actual experiment resulted in 428 peas with green pods. So the question is, assuming that groups of 580 offspring peas are generated, find the mean and standard deviation for the numbers of peas with the green pods. So we're going to take a similar approach for this. I'm going to erase this from that previous slide. Now I'm going to answer on slide 29. So here n is 580. Okay, so we're going to put 580 times 0.75, and then the variance is going to be 580 times 0.75 times 0.25, and then the standard deviation is going to be the square root of that, 0.25. Okay, so from here, what I'm going to do is just type them into the calculator, and that'll be my result here for each of these. So the mean, or the expected value, we would expect 435 green peas. The standard deviation, we'd expect this to vary by 108. 0.75. and then the square root of that would be 10.428. Okay, so there they are. That's that would be A on slide 29. B says use the range rule of thumb to find the number of peas with green pods that separate significantly low and significantly high values from values that are not significant. Okay, so we're going to answer that first part. We learned from class that significantly high would be mu, or significantly low would be mu minus 2 times the standard deviation, and significantly high would be mu plus 2 times the standard deviation. So anything within these calculations would be significantly, or not significant actually, anything outside would be significant. So let's go ahead and do these. So the mean we have here, 435 minus 2 times our standard deviation, 10.4828. We're going to find that, and then we're also going to do 435 plus 2 times 10.428. So we'll find that calculation. So let's do that. And we get, let's see, 435 minus 2 times 10.428. Then the same thing, I'm going to edit it and change it to plus. So I get 414.144. And then 455.856. Okay, and so let's look at the follow-up question on B, which it says, based on those numbers, can we conclude that Mendel actual result of 428 peas with green pods is significantly low or significantly high? Does this suggest that Mendel's value of 75% is wrong? So Mendel's value in the actual experiment was 428, which falls within these two, so therefore it's not significantly different from what he predicted. So Mendel's value of 428 green pods in his experiment is not significant. Okay, now since it falls within these two values, now it also asks one more follow-up question. Does this suggest Mendel's value of 75% is wrong? No, it actually doesn't suggest that it's wrong. It actually supports it. This does not suggest it's wrong. This does not suggest Mendel's value of 75% green pods is incorrect, because the actual experimental result was not significantly different. Since 428 was not significantly different. Okay, period. Okay, so that answers slide 29, and we'll go on to slide 30.